Welcome back. We are going to solve problems, suggested problem for chapter 5. This problem say, without doing any calculation, decide whether the tension T in the figure 5.23 will be equal, greater than, or less than the weight of the subject, of the object. The weight of the object is this force, mg. So, the diagram, or the free body diagram of the mass m will indicate that there is a force mg going downwards. There is a force, a tension force done by the rope here, and there is the tension. So this object is at acceleration 0, is not accelerating. So the sum of all the forces have to be 0. So the tension T need to have a components that make equilibrium with the weight. And the tension T need to have another component, that is this one, that will balance the force that the rope is doing on the mass. So because this is the hypotenuse of a triangle, this is bigger. So the magnitude of T is bigger than the magnitude of mg. That's all. That's all. Okay, another question. It say an artist wearing a spear. Okay, it say there is a force exerting on the object of 4 kilograms, that is 36 newtons. So 36 newtons is the force acting on the 4 kilogram. Good. So what acceleration produced 36 newton on the 24 kilograms? The acceleration that will produce this force on this mass, 24 kilograms, will be the force divided by the mass. Will be 36 divided by 24, which is 3/2. So the acceleration is 3/2. So now let's go to think. The problem is asking me if he pulled with 36 newtons on the 4 kilogram, on the 20 kilograms, which force will exist? Well, the 20 kilogram is also accelerating at 3/2. So the force is the mass by the acceleration. The force is what I don't know. The mass is 20 kilograms. The acceleration is 3/2. So the force is 30 newtons. So the girl is pulling the 4 kilograms with 36 newtons, but you only need 30 newtons to move the 20 kilograms with an acceleration of 3/2. So the result is 30 newtons. So is the option B. Option B. Okay. Let's go to the next one. Now read this problem and try to solve it by yourself. This problem says that you have two masses. Capital M is a big mass, little m is a small mass. Here on the capital M there is the weight acting on the body, and there is some tension going up. And on little m there is only T acting on the body. So let's go to read the problem. As more and more mass is added on little m, so you increase the mass m, maybe you start with 10 kilograms, 1 kilogram. You maintain fixed the 10 kilograms, so you add 1 kilogram more, so it's 2 kilograms. Now you maintain fixed the 10 kilograms, so it will be a weight of 10 by 10, 100 newtons going downwards. So now the mass m will be 3 kilograms. Now you maintain the weight m fixed, let's say 10 kilograms, and you add another kilogram here. What will happen when you are adding more kilograms? On the little m, there will always be a tension T, pulling the object, accelerating, trying to accelerate it in this direction. and the acceleration will be the tension divided by the mass. This is the only force that is acting on M because there is no friction. Well, there are another two forces that is not taking place. The motion is irrelevant because it's the weight, mg, and the normal n that is equal to the mg because there is no acceleration in the x direction, in the y direction. The acceleration is only in the x direction. So as a conclusion, we think on one-dimensional problem, this is the m, and this is the only tension T. Okay. So when I increase the mass to 2m, the tension will exist. The tension will be smaller or bigger. Well, as you increasing the mass, the tension here will be bigger. If you increase the mass to 3m, the tension will be even bigger. And if you increase the mass to 5m, 5 times its mass, the tension will be bigger. Wow, how I can conclude this? So let me solve the problem. Okay, let me read what it say. It say, the acceleration remains the same in all cases, since there is no friction and the pull of gravity of m is the same. Well, the acceleration doesn't remain the same because the tension T acting on little m is changing. As I'm increasing the mass here, the tension will be bigger. We'll see why the tension will be bigger. The acceleration becomes zero when enough weight is added to the mass. So when you put this mass little m, you convert it in capital M in the same big mass, it says that the acceleration will be zero, and it's not true. We will see why it's not true. The velocity becomes zero when m equal m, another option. The velocity, I think, is not true. None of the preceding, so this one should be none of the preceding statement. But the only way to analyze this problem is to solve the problem. Okay, let's go to solve the problem. So this is the problem, the solution to the problem. For the mass m, for the capital M, there is the weight mg, and there is the tension T going up. So if there is acceleration, it's acceleration downwards. So the mg will be positive. So mg minus T will be, mg minus T will be mass by acceleration. Mass by acceleration. So this is the equation, the Newton's equation for the object of mass capital M. For the object of mass little m, there is only one force, the T. So the equation is T equal m by a is the only force acting on this direction. So the acceleration is T divided by m. So I will plug in this number here. No, I will not do these things. I will plug in the a here, and I will say this equation, the first equation, equation 1, equation 2. Equation 1 will read like this. mg minus t, equation 1, equal m by a. By a is t divided by m. So mg is t, common factor, m divided by m, this is this, and t by 1 is this t when you pass it to the other side. So the tension T will be, solving, will be mg, m by g, mg, m by g, divided by this factor, m divided by m plus 1. So now suppose that m, little m, is 0.5 of capital M. Is half, is 1/2, little m is 1/2 of capital M. If little m is 1/2 of capital M, m divided by m will be 1/2. right? M divided by M, and M divided by M will be 2. So this is the term that appears here, M divided by M. So this will be 2 in this case. If M is 0.5 times capital M, M divided by capital M divided by M, capital M divided by M will be 2. So the tension will be M by G, 2 plus 1, 3. So 1/3 of mg will be the tension. Now let's increase the little m to 1m. Instead of half of m, 1m. What will happen? The tension will be the mass m by g, and now m divided by m is 1. 1 plus 1 is 2. So the tension will be half of the weight of the other object. So the tension is increasing when the mass is increasing. The tension is increasing when the mass is increasing. So if the tension is increasing when the mass is increasing, the acceleration on the mass will be always the acceleration on little m. This is the tension. The acceleration will be the tension divided by the mass of the object. And the tension for this case, for example, the acceleration of little m will be the tension divided by the mass. The tension is 1/3 of capital M divided by g divided by m. So this is the acceleration. In this case, the acceleration will be 1/3 m divided by m by g, or in this case the acceleration will be 1/3, but now capital M divided by m, capital M divided by m is the 2. You see, if m is equal to 1/2 of m, 0.5, capital M divided by m is 2. So 2/3 of g. So this is the acceleration of the body. What happened in this case? What will happen in the second case, in this m equal 1m? The acceleration of little m, of the mass little m, will be the tension divided by the mass. The tension for this case is 1/2 m by g divided by m. So the acceleration for this case, when the mass little m is converted in something equal to m, the acceleration will be 1/2 capital M divided by m by g. So it will be 1/2 1 by g, because m divided by m is 1, because m is equal little m. Little m is equal capital M. So m divided, so in this case the acceleration will be 1/2 of g. Interesting. So this is the problem. None of the options that they say is valid. And the solution is made by solving Newton's equation. Equation 1 will say, or apply to the capital M, will say mg, m, capital Mg minus t, the A is going downwards, mg minus t equal ma. And equation 2 is that the t acting on little m is m by a, because it's the only force. Working with this equation, you can solve it for t, and you will realize that this is the equation. Now you have to analyze the fraction m divided by m. So this is the problem. Okay, to solve this problem, we need to apply Newton's law for equilibrium, no acceleration. So the Newton's law for equilibrium will say that the sum of all the forces in the x direction will be 0, and the sum of all the forces in the y direction will be 0, meaning that there is no acceleration in the y direction, or if there is no acceleration in the x direction. So we are going to apply Newton's law to each body. Let's say that we start with the 150 newtons, so it has 150 newtons going downwards. This is the weight. So the body that it's say 150, have a weight of 150 newtons, so his mass is 15 kilograms indeed. So the body is in equilibrium, so it means that there is another force going up that opposed to this force in a way that the sum is zero. So T3 going up minus 150 going downwards will make a zero acceleration. So T3 have to be 150, so we found the first force. The first force is T3 when 150, and it's the force that is here, is on the 150 newtons, is the force of 150. On the body, 150 newtons needs to have. So this force is acting on the body of 72. So we go now to the body of 72 newtons. So it means that it has a force of 72 newtons going downwards. What are the forces that are acting on this body? Is the 72 newtons, is the T1, is the T2, and there is also the T3 pulling down. Is the force that the rope is doing on the mass of 7.2 kilograms. And this force is 150 newtons, so it's going downwards. So I have, what I have to say, to sum the forces of the x direction equals 0. To sum the forces in the y direction equals 0. Let's go to do the first things. To sum in the x direction. In the x direction, I see the force, the component of T1 in the x direction, that will be this one, and the magnitude will be T1 cosine of 60. I see the component of T2 in the x direction, that will be this one, and is T2 cosine of 60, but in the negative direction. And the sum should be 0, so that implies that T1 equal T2, and we call it T. So in the y, so I have applied the Newton's law for the x direction. Let's go to do it for the y direction. In the y direction, I see a force going downwards 72, a force going downwards 150, and I see the components of T1 going upward. And how much is this component? Is T1 sine of 60. Also, I see the component T2 going upward. Is T2 sine of 60. So T1 sine of 60 plus T2 sine of 60 minus what forces are going downwards, 72 and 150, will produce an equation like this equals 0 because there is no acceleration in the y direction. So T1 and T2 are the same, so the equation I would write it like this: T is sine of 60 plus T is sine of 60, because T1 equal T2 equal T. So this will be 2T sine of 60. 2T sine of 60 equal to 222. So the tension T that exists on the rope sustaining the body of 72 newtons or 7.2 kilogram will be, T will be 222 divided by 2 sine of 60, 2 sine of 60. So this is the tension T. You can make the calculation how much it will be, and make the calculation, and T3 will be 150. So we found all the tensions in the cables, 150 from the tension between the two masses, and the tension that are holding the mass of 7.2 kilograms is this amount of tension in the direction with 60 degrees to the x-axis. Okay, let's go to the next problem. Okay, let's go to solve this problem. This is a guy crossing a bridge or whatever, rock cliff, by slowing down. Okay, it's he stopped here in the middle of the rope, and it said that the rope will break if the tension on the rope is more than 2.5 by 10 to the 4 newtons. The mass of the guy is 90 kilograms. It's a question A. If the angle is 10 degrees, find the tension in the rope. Okay, let's go to do it. So we are going to apply Newton's law. The sum of all the forces in the x direction will be 0. So that will mean that on the object, on the guy, This is the guy. The guy have a force of 900 newtons going downwards. There is a tension going in this direction under 10 degree, and there is another tension T2 going under 10 degree. The symmetry will say that T1 is equal to T2, but anyway, Newton's law will say that T1 is equal to T2. The magnitude of T1 equal to T2. So the sum of all the forces, I see the component of T1 going to the right, this component, this one, and the value is T1 cosine of 10. Later on I see T2 cosine of 10 going to the left, so it's minus T2 cosine of 10 going to the left, and the sum of all the forces, forces to the right are positive, forces to the left are negative, is T1 cosine of 10 minus T2 cosine of 10, and this equation, what it will say that T1 is equal to T2. So we will use this fact for the sum of all the forces in the y direction. The sum of the forces in the y direction is 0 because there is no acceleration in the y direction. So this is mass by acceleration, but because the acceleration is 0, the mass of the object is 90 kilograms, it's not 0, but the acceleration is 0. So the sum of all the forces, I see T1, the component of T1 going up here, this T1 is going up, T1, and I see another component that is the same one going, so there is 2 times T1 sine of t. So this is T1 sine of 10, and this is T2 sine of 10. So there are 2 forces going up, and 1 force going down, the 900. So what is the sum? T1 sine of 10 going up, T2 sine of 10 going up, 900 going downwards. The sum is this, equals 0. So 2t sine of 10 will be 900. So what will be t? T will be 900 divided by 2 times sine of 10. The problem, the second part of the problem is solved for the part A. The second part of the problem is using this equation, t equal 900 divided by 2 sine of theta. So we write t equal the tension T, or let's say we do it here, 2t sine of theta is the force that going up, and 900 is the force that is going downwards. So the Newton's equation will say 2t sine of theta minus 900 equals 0. The sum of all the forces in the y direction equals 0. From this equation we have this equation, and for this equation we have that the t, or the sine of theta, we are looking for the sine of theta, will be 900 divided by 2t. So if they give me the t, the bracket point when the tension T is 2.5 by 10 to the 4 newtons, I will know what angle corresponds this tension. So sine of theta will be 900 divided by 2t. So the tension T is given. It says the breaking tension to break the rope. So you not exceed more than this angle, because the angle, which angle is this one? Well, this is what we are going to find, the angle. So sine of theta is 900 divided by 2t, and the maximum t is 2.5. So sine of theta will be 900 divided by 2 by 2.55 by 10 to the 4. 10 raised to the power 4, 900 will be 900 divided by 5 is 180. 10 raised to the 4 will appear here 10 to the minus 4, and this will be 0.018 radians. So sine of theta is 0.018 radians. So theta is arc sine of 0.01 radian, which is theta is 1.03 radians. So it corresponds to more or less 55 degrees, something like this. So at this angle, the rope will break. Okay, that's the problem. Okay, the problem is a car. The mass of the car is 1,130 kilograms. There is a cable. You read the problem, of course. There is a cable. There is a tension that is pulling here. The cable makes an angle of 31 degrees here about the surface of the ram, and the ram is 25 degrees. about draw a free diagram body. A free body diagram will be the object and the forces that are acting. I see the mg going downwards. I see the tension through the angle 31 degrees through the x prime direction. This is the horizontal to the floor, x prime direction, 31 degree. And I see the normal force going upward. That is the force that the floor is exerting on the car. Okay, so there are three forces, the normal force, the tension, and the weight. So these three forces, tension, they sum, and they sum to be what? 0? Well, the problem doesn't say anything, but I suppose that he wants to create a motion of the car with constant velocity. So the acceleration is 0. So it doesn't say on the problem, it should say, okay, draw a free diagram is done. Find the tension in the cable. We are going to find the tension in the cable in the case that the acceleration is 0. So we are going to write the sum of all the forces through the x prime direction. This is the x prime direction. What is the forces? I see the component of t in this direction, t cosine of 31. And I see the mg sine of 25 in the negative direction. mg, this is 25. mg cosine of 25 will be all this, and mg sine of 25 will be all this. So t cosine of 31 minus mg sine of 25 equals 0, or what is the same, t cosine of 31 equal mg sine of 25. So the t will be mg sine of 25 divided by cosine of 31. Because we know mg, we already know the tension. mg is 11,300, and this you need to calculate, please. You calculate it, and you know the tension. Now let's go to the sum of all the forces in the y direction. So in the y direction, there is also no acceleration. Y prime direction, there is no acceleration, meaning that the body is not changing its velocity in this direction. It's a constant velocity. Sum of all the forces in the y direction will be, I see the t projected to the y-axis is t sine of 31 going up. I see the normal going up, and I see mg cosine of 25 going downwards. So the equation is, what is going up? T sine of 31, this component of this force through the y direction. The normal is going up, and mg cosine of 25, the component of this mg, this force, this is mg cosine of 25, this is going downwards. So the sum of all the forces equals 0, so I have the normal. The normal will be mg cosine of 25 minus t sine of 31, but I already know the tension T from the first part. The tension T is 11,300 sine of 25 divided by cosine of 31. So the normal force is 11,300 cosine of 25 minus 11,000 sine of 25. Tangent sine in between cosine is tangent of 31. And this is the result. Of course, you need to use your calculator and to find what is the normal. The normal force you will find, and you will find here what is the tension, exactly the correct number. Okay, that's the problem. Welcome back. Let's go to solve this problem. Please read carefully and come back. The problem say you have a ball like this one. The ball is the wall is making a force to the left. The ball is in equilibrium. The sum of all the forces is 0. So they give you the data that this is 0.11, the radius is 0.11, the length is 1.4, and this data allow you to find theta, because sine of theta is 0.11 divided by 1.4, so sine of theta is 0.078, but theta, it will be, when sine of theta is very small, when sine of theta is when theta is very small, smaller than 1 radians, sine of theta is more or less equal to theta. So theta is almost sine of theta. So this is 0.078 radians. If you don't believe me, you make a calculation in your calculators and you will find that is 0.078 radians, or approximately 5 degrees in degrees, 5 degrees. If you convert these radians to degrees, if you converted the radians to degree, it will be 5. So the first question say, make a free body diagrams. Well, I see 3 forces acting on the body. The tension going in this direction. This is 5 degrees. This is also 5 degrees. So is the tension, the weight mg, I know the m, I know the g. I know mg going downwards, and the force that the wall is doing on the object. There is no more forces acting on them. And the sum of the 3 forces should be 0. So the question we say, find the tension T. Well, we'll write this equation. We write Newton's equation. The sum of all the forces in the y direction equals 0 because there is no acceleration in the y direction. What are the forces in the y direction? I see the T, the projection of the T in the y direction is T cosine of 5. And there is mg going downwards. So T cosine of 5 minus mg should be 0. I don't see any of the forces in the y direction because this one is on the x direction, the minus x direction. So from this equation I can find the tension on the rope. The tension will be mg divided by cosine of 5, and you can make the calculation to find the value in your calculator. This will be approximately 27 because cosine of 5 should be very near to 1, so it will be 27 divided almost by 1, so a little bit bigger than 27. Okay. Now finding the F. Finding the F, we will do the equation, the sum of all the forces through the x-axis equals 0. What forces do you see in the x-axis? Well, I see the F going to the left, minus F. I see the T going to the right, the component of the T going to the right, but the component of the T, of the tension going to the right, is T sine of 5. So T sine of 5 going to the right minus F equals 0. So the F, you solve it for F, is T sine of 5. But T, we know T, is this amount, 27 divided by cosine of 5. So mg divided by cosine of 5 is sine of 5. So the force will be mg tangent of 5. Or if you want to plug in numbers, you plug in numbers. mg, 2.7 by 10, tangent of 5, you multiply, and this is the force. And the problem is done. Okay, please read this problem. Problem number 15. There are 2 blocks. There are equilibrium here. There is no acceleration of the body A and of the body B. The mass of the 2 bodies, they are the same, they say the problem. And it say calculate the tension in the rope here, connecting the rope, the 2 masses, and on this rope, that is the force that the wall is doing on the body A. Okay, we do always the same. We choose the axis. This is the x-axis, x prime axis, we call it, and y prime axis, x prime. So we make a free body diagram. So this is the object B. The object B, there is a tension T1 going up, produced by the rope on the body B, T1. There is the weight mg going downwards, and there is no more forces. So I will apply Newton's law, the sum of all the forces on the x prime direction. This is the x prime direction. I see T1 going up, I will put it positive. And I see mg sine of alpha going in the negative direction, minus mg sine of alpha, going to in the negative direction. So the sum will be 0. This produces an equation that if I solve it, I will find T1. T1 is the weight mg by sine of alpha. Perfect. Now I will go to my body A. My body A, this one, it has several forces. T2 in the x direction. I'm looking now on the x direction. There are T2, the force that the wall or the rope is doing on the body A. T2, T1, the force that the rope is doing on the body A, going in this direction, T1, and mg. And the sum of the three forces must be 0 on the x direction and on the y direction. On the x direction, will produce an equation that will say T2 positive minus T1 negative minus M1 the mass G sine of alpha, because this is mg, but the projection of mg through the x prime axis will be mg sine of alpha. So this equation, I can simplify this equation into this equation T2 equal mg sine of alpha plus mg sine of alpha, because ma and mb are the same mass. They say the problem ma equal mb equal m. So T2 is 2 mg sine of alpha. So I have solved question V. Question V say the rod that connects the block, the tension connected the block T2 is 2 mg. And part C say calculate the magnitude of the force that the incline exert on each block. This is the normal force that is asking. This is the force that the inclined plane is doing on the body. So you make again a free body diagram. The normal force is going in this direction. The tension is going in the x direction. So I will make the sum of the forces in the y prime direction, in this direction, y prime direction, equals 0 because there is no acceleration. So there is the normal force going up, and the only force that is going downwards is the component of the weight in the y direction. The component of the weight mg in the y direction is mg cosine of theta. So this will produce an equation that will say the total force, the sum of all the forces, n minus mg cosine of theta will be 0. So the normal force will be mg cosine of theta. For the body A, will happen the same thing, because the body A have two forces, T1 and T2, but these forces are not affecting the motion on the equilibrium. It's happening in the y prime direction. So T1 and T2 have no projection on the y prime direction because they are perpendicular to the normal. So they will not have. So the result will be the same one. The component in the y prime direction is mg cosine of theta. This part is mg cosine of theta minus n, or if you prefer to place the equation n minus mg cosine of theta, like this equation, it will be valid, of course. The normal force is mg cosine of theta. So with this, we have solved all the equation, all the problems. We found T1, we found T2, and we found the normal on each, the normal force on each body. And the problem says if alpha equals 0, what will happen with this equation? If alpha equals 90 degrees, so the inclined plane is very inclined, it's inclined with 90 degrees. What will happen? Sine of 90 will be 1, so T1 will be mg, T1 will be mg, so the force here, T1, this force, if the angle become 90 degrees, T1 will become m1g, mg. And T2 will become 2mg, because if the angle is 90 degrees, sine of 90 will be 1, the tension 2 will be 2mg. It makes sense. Yes, of course. Now, if it's 90 degrees, they will be like this, m and n. So if you apply Newton's law again, you will find exactly the same result. This is equilibrium, so this body, this one, is in equilibrium, so the sum of the forces is zero. So M, I will draw a diagram of a free body diagram, so we'll have the tension T and we'll have mg. The sum, T minus mg, will be zero. So the tension will be mg. So now I will do the problem here. I will choose this box like my system, and I will say here there is a tension T. And the body, the system here inside, is in equilibrium, so there is force going up and there is force going down. 1 mg from this one and 1 mg for the other mass. And the sum will be zero, so the tension will be 2 mg. It's the same result that I found before. Well, that's the problem. Okay, let's go to solve this problem. It's there is an acceleration here. The train is moving with acceleration, it's changing its velocity. The acceleration is 3 meters per second square. So the question is that there is an ma of the mass, there is an acceleration. So the mass m that is holding, hanging here, have mass by acceleration in this direction. So what are the forces that can create mass total force ma equal this force? Well, I need to have the tension in this direction, the weight in this direction. Now the sum of the tension in this direction plus the weight mg, T plus mg will produce ma. The sum of all the forces equal mass by the acceleration. The sum is the tension, the vector T plus the vector mg equal ma. So the only situation, if you are accelerating to the right, ma is going to the right. So the only forces that are acting by an inertial observing is observing only the tension and the weight mg that I put it here, mg. And the total force is ma, so this is the picture, the good picture that you have to take in account. So the tension T going upwards, the component of the tension going upwards will cancel with mg to produce only a tension in the x direction. So the tension in the x direction is the one that is being accelerated in the body. So the tension Tx will be m by ax. So this problem we have done before, I think. And it's quite a confusing problem because this is the key things, I think, to understand. This is the key thing. The sum of all the forces, T plus mg, must be ma. So if this is happening, the sum of all the forces is equal ma, T plus mg, ma. I can suppose that the component you see here, the T components, these components, will cancel with the mg. T component, the T, Y component will cancel with the mg. So if you prefer, I put the figure like this. This is mg, this is the T, and the T is converted into two pieces, two components, Tx and Ty. This T will cancel with mg. So the equation for the y-axis will be T in the direction of y is T cosine of theta minus mg equals 0. And the T in the direction of the x is T sine of theta. So T sine of theta is this. This is the T. This is the angle theta. This is the angle theta, that is the same that this theta, that this one on the picture. this theta is the same as this theta. Okay, so t cosine of theta will be upwards, minus mg will be 0, so t will be mg divided by cosine of theta. So this is the tension. And on the x direction, the sum of all the forces is Tx, is the only force that is on the x direction. Tx, the only force that is on the x direction. Tx equal m by ax, but Tx is t sine of theta equal mx. So t is mg cosine of theta, mg cosine of theta by sine of theta equal ma. So the m will cancel and will produce an equation that it will be g sine of theta divided by cosine of theta is tangent of theta, g tangent of theta equals 3. So tangent of theta equals 3 divided by g, or 3 divided by 10, or 0.3. So theta will be 0.29 radians, or theta, the angle will be 70 degrees. So the angle will be in the clockwise direction, is going to the left, the angle, okay, and it will be like this picture for an acceleration going in this direction. Now the car is moving towards the left with, I leave you this part. The car is moving to the, I leave you this part for you, okay? The car is moving toward the left with constant velocity 4 meters per second. It is moving with constant velocity 4 meters per second. The sum of all the forces is 0, so the angle should be 0. So in this case, the situation is like this. This is the train. This is the ball. So the acceleration is 0, so there is no change in velocity. This is the observer. The observer is here observing the tension T and the weight mg. And he will say, okay, there is no acceleration, there is no change in velocity. So T minus mg equal ma. But a, the acceleration in the y direction, is 0. So equals 0. So T equal mg. And he will see the angle theta equals 0 for this case. So try to do the part B that is interesting and reproduce the result. I hope I have been clear enough to solve this problem. So the question is like this: when you see an object with acceleration, the object of mass will have a vector that is m by a. And whatever it happens, the sum of all the forces have to be m by a. For example, it could be a force like this one, and another force like this one. And the sum will produce ma. So now, ma will be like this, ma. The sum of the forces F1 and F2 will produce ma. So I hope you can catch it. Let's go to the next. Okay, stopping distance of a car. So you have a car. Please read the problem. You have the car is moving at 29 meters per second. There is friction, so the friction is producing an acceleration in this direction, in the opposite direction of the velocity, and eventually the final velocity will be 0. So it says the mu sub k, the mu sub k is 0.8. What will be the distance that he can travel until Vf is 0, until the moment that Vf is 0. So the friction force is mu sub k by the normal. In this case, the normal is mg. So the friction force is the force minus 0.8 mg. So the acceleration is minus 8 meters per second square. So the car is reducing its velocity in 8 meters per second every second. But the problem is about distance. It's not about time. So we need to use this equation that we will use when we start studying work and energy, that say that V final square is the relation between V final square and V initial and the displacement related with the acceleration. V final square minus V initial square is 2 times A by delta x. V final square will be 0. V initial square is what we know, 29. equal to times a is minus 8 by delta x. So we have to find delta x. So delta x will be minus v0 squared minus v0 squared divided by minus 16. So delta x it will be 52.5. What it means that? It means that the car will displace the 52.5 meters until he finally stops with velocity v0. So delta x will be 52.5 meters. The second part of the problem say what happens if the coefficient is smaller, and they ask you to stop in these 52 meters. What is the initial velocity that you should have? Well, now the coefficient is 0.25, means that the friction is smaller. It means that the acceleration or deceleration or the negative acceleration will be smaller. So we do the problem again. The friction force is minus mu by the normal. Mu is 0.25 equal mg, and the sum of all the forces acting on the body is equal to the mass by the acceleration, because there is no any other force acting on this x direction. So the acceleration is minus 0.25 by g, so it's minus 2.5 meters per second squared. Now it's a smaller acceleration. So we use the same equation, but now we know that the final velocity is 0. We know that the displacement have to be 2.5, and what they ask is about the initial velocity. So v0, we plug in numbers, 0 minus v0 squared, unknown, 2 times 8 minus 2.5, and it has to stop in the distance delta x equal 52, so minus v0 squared minus 260, so the initial velocity should be 16 meters per second, a square root of 260. Okay. This is a problem that maybe you have done in the lab. It's about measuring the coefficient, the static coefficient of frictions. And the idea is the following one. This is the box, this is the angle. You start to increase the angle, and the box doesn't move, doesn't accelerate. You are going to measure the angle at which it will start to accelerate. It will accelerate downwards in this x prime direction. You know what is the x prime direction that I'm talking all the time. So the idea is to relate the static coefficient of frictions with the angle theta. And there is a easy relation that we will see now. So see like this. This is a free body diagram of the body. This is the weight, this is the normal, and there is the friction force. There is no more force acting on the body. So I will place the sum of the forces on the x prime direction. This is the x prime direction. I will choose the positive like this. Okay, the positive is going like this, so it will have mg sine of theta, that is the component of mg in the x direction, in the x prime direction, so this force. Now it will have a force, a friction force going up, going in the negative direction. Okay, and the sum will be 0 because still is not moving. I'm trying to catch the angle theta when he will start to accelerate. So this equation will say that mg sine of theta minus mu by the normal, because the friction force is mu by the normal, is 0. By the normal, you know that is mg cosine of theta. So the equation will say mg sine of theta minus mu by mg cosine of theta equals 0. So if I solve for this equation, mg sine of theta will be mu sub s mg cosine of theta. So the mu sub s will be the tangent of theta. When mu sub s, you start you have to find the mu sub s, the mu sub s or the mu dynamic. Which one is this one? Let me think. Which one is this one? This is the mu dynamic, because it's when it starts to move. So the mu dynamic is tangent of theta. This is the mu dynamic, not the mu static. the mu static, you will not be able to find it. Okay. Well, indeed, you can find the static coefficient of friction by reducing the angle. You reduce the angle in the labs. Now you reduce this angle theta is the angle at what you find mu sub d. So now you reduce the angle and you see when the object is moving with constant velocity, So V constant will means A equals 0 and will means that the force acting on the weight mg sine of theta will be equal to the friction force, but will be the static friction force at this angle theta. And the result will be mu by the normal mg cosine of theta is the friction force, should be equal to mg. It will be the same result but at different angle. So both equations will work. Mu dynamic will be a tangent of theta 1, and mu static will be tangent of theta 2 when the velocity v is constant. Here, the velocity will not be constant on this case. The body will fall accelerating. Now this is the second thing. Okay. Well, now I think that you are prepared to solve this problem by yourself. 48, 59. Atwood machine, we already solved it at class. This one is similar, you can solve it. This one is again the same equations, only that involve a friction force maybe. You have to take into account the friction force. Try to solve this one if you like. This one we have solved at a class also, very similar problem. And this one is the last one. You can try to solve it also. A block is placed again at the vertical front of a car as shown in the figure. What acceleration must the car have in order for the block A? A block is placed against the vertical what acceleration must have in order do not fall? Wow, let me think. Okay, let's go to solve it, this problem. The idea of this problem is that on the body A, the free body diagram will say that on the body A, there is a force acting on this direction that is the normal force. Is the force that the cart is doing on the block of mass A. Now, this friction force will increase if the normal force is bigger. So if the normal force is bigger, the friction force will increase, and the friction force will be eventually equal to mg, so the body will not fall down. It will be sustained by the friction force, the weight going downwards and the friction force. So how I will do this problem? I will write the Newton's law equation. The sum of all the forces on the x direction acting on the body A, the sum of all the forces is the normal, the F equal the mass is the only one in the x direction, N equal M by A, okay. And in the y direction, the forces are mg going downwards minus the friction going upward, and this is M by AY. I want to find a relation when AY is 0, that there is no acceleration going downwards. So this will be 0. Now, if this is 0, the equation will be the mass M. Let's go to plugging instead of MAM is the mass of the block. The mass A minus mu by the normal. Mu by the normal, but the normal is M by A. So the equation will be like this, equals 0. So let me rewrite this. So the equation will be m by g equal mu by m by a. The m will cancel, so the a is g divided by mu. So you need this acceleration to produce a friction force that will sustain the weight. We will produce an acceleration. With this acceleration in the x direction, you will produce a normal force big enough to sustain mg. So this is the acceleration. So if mu is 0.25, the acceleration is u is 10 divided by 1/4, which is 40 meters per second squared. So it's changing in 40 meters per second in every second. Wow, it's big acceleration. Your car cannot do it. Your car cannot do this acceleration, even if you press to the maximum. Okay, so the idea is, like I said, is like this. When the normal force increase, when the normal force increase because the acceleration is bigger, the normal force N is m by a. This is the only force that exists on the x direction. When the normal force increase, the friction force increase because it's mu by the normal. So when the friction force increase, eventually will reach the same amount of mg going downwards. And at this precise moment of this acceleration, you will find that the object is not falling down, sustained by the friction